Welcome to section 4.11, Polynomial Functions and Modeling, Day 1. Check it out, my math leads. Here we go. We've spent all of Chapter 3 talking about quadratic functions. And you know that when you've got a quadratic function like this, it's usually the form something x squared plus something x plus 3. There's usually three terms, often three terms. And you can actually factor that into x, for example, here, x plus 1, x minus 3. What we know is that creates two zeros. Sometimes there are two zeros. If the parabola intersects the x-axis, then there will be the two real numbers here. For example, -1 and -3. Those are the zeros. The x-intercepts are the points, the corresponding locations on the graph where you get zeros. -1, 0, 3, 0. The y-intercept here, you can see along the y-axis, it happens to intersect it at the point 0, -3. It has a minimum value of -4. There is no maximum value because it keeps on going up forever and ever into infinity, positive infinity here, so there's none. You can say, therefore, the domain is -infinity to positive infinity because we don't have to worry about anything creating a 0 in the denominator or a negative in the square root. And the range is -4, starting at the value -4, including -4, all the way up to positive infinity there. That's a quadratic function, and it's a special kind of what we're going to call polynomial functions. Here's another special kind of polynomial function. You can see it's a function made up of polynomials. This polynomial here can be factored into three factors: x plus 4, x plus 1, x minus 3. And actually, although this is the easy way to kind of read it and type it into Desmos or whatever, this is the standard form, this factored form gives us a lot of information. And a lot of our effort in Chapter 4 is going to go towards figuring out how we can go from this form to this form. Because you can see when you have this, then automatically you don't even have to look at the graph. The zeros are going to be -4, -1, and +3. They correspond to these three locations, these three x-intercepts along the x-axis. Here the x-intercepts just identified the 3 points where the graph will cross the x-axis. And here's the y-intercept at -12, 0, -12. We see a relative minimum down here at -20.7 when x is equal to 1.4. We see a relative maximum value at 12.6 when x is equal to -2.7. The domain and the range are both all real numbers. These are two different examples of polynomial functions. So here you can see here's polynomial function, here's another polynomial function, because it's made up of a polynomial. Here's another polynomial function. You can see here we've got a polynomial, and when you graph it, it's a polynomial function. Here are some non-polynomial functions because, as you might remember, these kinds of expressions are not polynomials. The absolute value is not a polynomial. The square root symbol doesn't create polynomials, and when you have fractional exponents, then they create things that are not polynomials. All polynomials look like this. They're just lots of terms added to each other. Boom, 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 boom. And then you have n, n-1, n-2. These are all integers. And then the coefficients, the a values, the a of n, then the a of n-1, all the way down to the a0, they're all real numbers, and the exponents are all whole numbers. Great, so that's what a polynomial function is in general. And you can see we can kind of break them up into two different categories of polynomials. Where the category where you have an even degree, the first term, or the highest exponent is even, 2, 4, 6, 10. Highest exponent is even. And then an odd degree, where the highest exponent is odd, 3, 5, 7, 9. So the degree is, the degree of a polynomial is, as you might remember from, I think it was Chapter 1, the degree of a polynomial is the highest exponent. And then the leading term of a polynomial is the term with the highest exponent. Turns out that highest exponent, that first term, dictates a lot about what the graph is going to look like. So here would be the leading term, and n would be the degree of the polynomial. So let's just make sure we understand our terminology. We've got a constant function here where it's just f of 3. That's constant. It's going to be a flat line. Linear, it's going to be a straight line. You recognize this y equals mx plus b, where the exponent is just 1. The degree is 1. The quadratic, where the degree is cubic, where the degree is 3. Quartic, where the degree is 4. And it keeps on going up. And then let's examine exactly what the degree is. Okay, so you can see here the degree is 0, 0, 1, 2, 3, 4. That's just the highest exponent. 0, 1, 2, 3, 4. You can think of 3 as 3x to the 0 because anything to the 0 is just 1. And you can remember that there's an invisible 1 here. Make sure you copy down what you see in blue. Just to move along in the table, the leading term is that term that has the highest exponent. So you can see here that the constant term is just going to give you a leading term of 3. That's the only term there. The leading coefficient is 3. It might be easier to see on the quartic. You can see if you rearrange them in terms of descending exponents, then the leading term is going to be this first one. It's negative x to the 4th, and its leading coefficient is the invisible negative 1 in front. Here there's a leading term is x cubed, and the leading coefficient is 1. Here the leading term is 4x squared, and the leading coefficient is 4. 2/3 x, 2/3 x, 2/3. So when we examine this leading term and the leading coefficient, it gives us clues as to what the graph looks like. Here is a pretty important table to talk about end behavior. And end behavior is the behavior of a graph as x goes to positive infinity and negative infinity. What that means is you can have, if you know what the end behavior is, you might have lots of crazy stuff going on in the middle, but eventually the graph will go up to positive infinity, or maybe negative infinity, negative infinity. In fact, if you know what the leading coefficient is, if you know that the leading coefficient is positive, then it'll behave like those two graphs. And if it's negative, that's what these inequalities mean. Yikes. A of n here is greater than 0. A of n is less than 0, that's negative. Then you can see something like, this would be like the graph of y equals x squared. It's going up to positive infinity. This would be the graph of y equals x cubed. This would be the graph of y equals negative x squared. The whole thing gets flipped. This would be the graph of y equals negative x cubed here. So if you know about the first term, the leading coefficient, then you can determine a lot about the graph. It says, using the leading term test, match each of the following functions with one of the graphs a through d which follow. So a here is the leading term is 3x to the 4th. It's a degree of 4. That's even. So you can see 3x to the 4th in part A, it's 3x to the 4th. The degree of the leading term is 4. Right here you can see it's a 4, which is even. And the sign of the leading coefficient, 4, is positive. So therefore, although we might really know what's going on in the middle, what we're looking for is both ends of the graph to go up to positive infinity. That's why you can see just from 3x to the 4th, you'll know that eventually it'll go up to positive infinity on both sides. Here we can see that for part B, let me move it up a little bit. Part B, we can see that the degree of the leading term is 3, which is odd. So we're going to use these. It's going to be one of these two, and then the sign of the leading coefficient is negative. Because the sign of the leading coefficient is negative, we're now going to have coming in. It's going to go to the left. It's going to go to positive infinity, and to the right, it's going to go down to negative infinity. That's not A. It's not B. Oh yeah, it is B. There it is. goes up to positive infinity and goes down to negative infinity. So that's why you know this is b right here. C, the leading term is x to the fifth. You can see it's in the problem, it's x to the fifth. And then the degree of the leading term is 5, which is odd. So it's going to be one of these odd behaviors. And then the sign is positive. The sign is just 1, and then the invisible 1 right here. So that means it's going to go up to positive infinity to the right and down to negative infinity to the left. That looks like graph A. I'd like you to do part D, and then when you're finished, I would like you to start the assignment. Copy the problem list and do the first problem. And I'll see you in class. Oh, by the way, did I say that that I've been to Manila before? Probably have. This is your audio check, and you can say that if you've ever been to the Philippines in Manila, then let me know, and I'll see you in class.